Hello students, in the previous lecture I discussed about the segment registers, the segmented memory, the instruction and pointer registers. Now in this lecture I'll tell you how to make 20-bit physical address, how to generate 20-bit physical address for 8086 microprocessor. As I've told you, all the segment registers, they store just the 16-bit. The segment registers, the instruction pointer registers, they are 16-bit wide. So how to form 20-bit address using these registers? So to access a specific memory location from any segment, we need 20-bit physical address. The 8086 generates this address using the contents of segment register and the offset register associated with it. We know that the code segment register holds the base address of the code segment. The 8086 provides an instruction pointer which holds the 16-bit address of the next code byte within the code segment. The value contained in the instruction pointer is referred to as offset. This value must be offset from the segment base address in the code segment to produce the required 20-bit physical address. The contents of the code segment register are multiplied by 16, which means they are shifted by 4 positions to the left by inserting 4 0 bits, and then the offset, that is the content of IP register, are added to the shifted contents of the code segment to generate physical address. So let me show you how this happens. So this is the up to this point is the code segment register. Code segment register is storing the data 34BA, and this is the data of 8A, sorry, instruction pointer. This is the data of instruction pointer, that is 8AB4. Now using code segment and instruction pointer, how we can make the 20-bit physical address? First we need to shift the code segment data by 4 position to the left and insert 0. So if you convert 34BA to the binary form and you shift this binary number by 4 positions to the left and insert 4 zeros, then ultimately convert it into the hexadecimal form and you will get 34BA0. Now in the 34BA0 data, you need to add the instruction pointer data and you will get 3D654, that is the next data from where the instruction needs to be fetched. So this is the code segment. This is the code segment, and the 34BA0 is the starting address of the code segment, which is actually given by code segment register, and by adding the content of instruction pointer you will get to find that location from where the instruction needs to be fetched. So now we have seen that how 20-bit physical address is generated within the code segment. In the similar way, the 20-bit physical address is generated in other segments. However, it is important to note that each segment requires particular segment register and offset register to generate 20-bit physical address. So as I've shown here also, as what I was telling you, if you need to access any memory location in any segment, you need the segment register. So the segment register needs to shift by 4 position to the left, and in zeros need to be inserted, and into that you need to add the content of address and you will get the required address. This is the required address. So this is how I have shown. Again, the same thing has been shown here. The segment register value has been shifted by 4 values to the left. Zeros has been inserted. After adding offset and segment register using the adder, you'll get 20-bit physical address. So as I was telling you, every individual segment needs a segment register and offset register. So for code segment, code segment, the starting address is given by code segment register and the offset is stored by instruction pointer. For stack segment, the starting address is stored by stack segment register and the offset address is stored by either stack pointer or base pointer depending upon the addressing mode. For data segment, the starting address is stored by data segment register and the offset address is stored by BX register or source index register. Similarly, data segment, the starting address is given by data segment register, and for other than string operations, destination index is used for storing the offset. Even for extra segment register, the extra segment register is used for storing the starting address of extra segment, and destination index is used to store the offset of extra segment. So this was all about the architecture of 8086 microprocessor. Next we going to start the pin configuration of 8086 microprocessor. In my next lecture I am ending this class here. Thank you.